Hey, what's up guys, Jeremy here. It's now time to look at 3D paths using the Curve Follower project. Let's get started. For this example, we will use the 10D Fanic Training 3D Dispensing.rdk file. It's again a relatively simple path using a Fanic robot, a dispensing tool, a table, and this time instead of using a flat part, we're using a 3D part. So we have here three different paths that I want to show you. So the first one will be path 3 axis here. So the first one, like I said, like it says in the name, this one will be a path that only uses 3 axis instead of 5 axis. So for the first example, I was only using 2 axis, so X and Y. The Z was always staying at the same height. In this case here, we'll be using 3 axis. So we have X, Y, and a Z. So if I go to Utilities and then Curve Follower Project, I will close this one already and I will rename it here. 3, oops. I'm gonna go path 3 axis. I was about to start with the 3 first, but I would highly recommend not starting any program name with a number. It will work within RoboDK, but most robot controller won't like it. So I started with path instead. So the only thing I need to do is like go and select the curve. Here you can see this curve is just one complete curve. So if I select it here, it starts from the 1 here and goes all the way around to 0.2 here, like that. Cool. So I can go ahead and select and create my NTS approach and retract motion because I like those a lot and it doesn't take a long time to create them. I moved that a bit too much to the side. Perfect. And create my normal 50. I can copy that out here, paste that here. Awesome. So like that, param event, I will go param start and param finish. I have a gun start instead of gun on. It's called gun start, and then gun end instead of gun on, gun off. Click update, and then I can simulate that. Here you can see that there was a change in the selected configuration. I didn't like that, so I'm gonna go move that home here. Okay, that's because the tool is rotated 180 degree in this case. Just gonna move that here to 180. I will bring the TCP up. I will bring that down here. Move that here. I will help RoboDK a bit define which configuration I would like to prefer starting from. Like that, I will say set current, update, and then I can close this here. And then I can simulate. So for a 3, and you can see here I have another color, another size of bit. So I just modified the Python macro so that here it's better. Okay, so here, first of all, you see that we have a small rotation, mostly because we are potentially hitting a joint limit. So joint limits of 4. So I should modify that here by bringing back my robot to the starting point. I can say, okay, I'm too close to my joint 4 starting point, so I will make it like that here. I will make it like this here. I will make it like that here. So this will be my starting point here. Set current, update, and then simulate so that I really have something where I'm not close to any singularity or joint limits, so that I won't have to rotate around. So I would even prefer kind of doing that here, updating to make sure that I don't use the optimization parameters. So if you don't have to use them, make sure to not use them. It's always a better option. Okay, so now if we look at the path here, as this path is a 3-axis path, all the normals are pointing towards the sky again. The only thing that differs is that we are changing the Z value along the path. So that's very similar to what we did before, and there is not much that needs to be changed in this project here. Great. Okay. So let's do the same for another path. So if I hide this one here, I can hide the tool path. I can hide this path here, and I can make this path here visible. Now you will see that the normals, instead of being all pointing towards the sky, they are all normal to the surface they are linked to. So here, as you can see, those normal are at a 45-degree angle because the part is at a 45-degree angle, and this section of the part is at 45-degree, in fact. And here you can see if we go near the curve here, we have a curvature, so the normals are kind of changing slowly but surely from, let's say, towards the sky to 45-degree angle, and then again here changing from 45-degree to pointing towards the sky directly. So that's great. Just like that, perfect. So now I will go utilities, or I can even do something better than that. Control C and then Control V. If you do that, make sure to delete this one here because this one will still be linked to it. So just delete the param that was generated. I will change that for 5-axis. Select here, select curve, reset selection. Now I'm selecting the new curve here. Click done. I have all the same settings because I copied the whole project. Update, and then I can simulate like that here. For some reason the bid didn't start, so that can happen, like I said before. And now I will have a rotation here, and you can see that the tool is now following the surface. In fact, it's always normal to the surface. The first one was only following the XYZ position of the surface or the groove that we need to fill, but this one here is really following the orientation of the surface too. So that's great. Cool. So now we can really see, if I update this one here, update program, you can really see the difference between a 3-axis path where we are normal to the ground at all time, and a 5-axis path where we are normal to the surface of the part we are working on. So both are possible. Obviously, it will depend on how you import or extract the path itself. So in this case here, the path is already extracted, so this part is already done. So the curve follow project is only kind of taking that information or that data and applying it to the tool orientation. But like I already said, in the next module, I will show you how to extract that path or how to import a path. So this is where kind of the magic happens to define if you're using a 3-axis or a 5-axis path. Okay, so that's pretty much everything for this video. In the next and last video of this module, I will continue showing you some kind of hidden but very useful options of the curve follow project. So I hope to see you there. And in any case, have a great day, guys.